Alright, in this video here we're going to talk about the laws of exponents and basically just do a bunch of examples that involve using the laws of exponents to simplify expressions. Alright, now if you haven't checked out my other video yet, I made a video that explains the laws of exponents and kind of why they are what they are and what those rules actually are. So if you haven't seen that yet, and if you're having trouble remembering the laws of exponents, I would advise you to check that video out. In this one here, we're just going to use the laws that we talked about previously to actually solve some problems. Alright, so the first one here, I have 4/7 in parentheses raised to the 0 power. Alright, well, if you recall the laws of exponents, anything raised to the 0 power equals 1, with one exception. Right? The exception to that is if I have 0 raised to the 0 power. 0 to the 0 power is just undefined. It doesn't really equal anything. It doesn't make any sense. Right? But any other base besides 0 raised to the 0 power is going to equal 1. Doesn't matter what that base is, as long as it's not a 0. Alright, so anytime you see a number or a variable or a whole big expression in parentheses raised to the 0 power, doesn't matter what that is, just make it a 1, you're done. Right? Pretty simple if you know what that rule is. Alright, the next one, number 2, x to the -1 power. Well, if you recall, a negative exponent means you take the reciprocal of that base raised to the positive of the exponent. Alright, I don't know if that made sense in words, but x to the -1 is the same as 1 over x to the +1. Right, so a negative exponent means basically flip it over, take the reciprocal. X to the -1 power is 1 over x to the +1. And when you flip it over, that negative exponent becomes positive when you put it down in the denominator. And x to the first power is just x. Right, so x to the -1 is equal to 1 over x. Right, and that is a fact that you will see, and it will come up again and again throughout precalculus, algebra, calculus. Using those negative exponents becomes a pretty important thing. So it's important to understand that the negative exponent means flip it over, take the reciprocal. All right, number 3 here, x to the 4th times x to the 7th. Well, if I'm multiplying two things that have the same base, I need to add the exponents in order to combine them together. All right, so x to the 4th times x to the 7th is x to the 4 plus 7, which is x to the 11th power. Right? And most teachers don't require you to write this middle step of x to the 4 plus 7th. I mean, most teachers would understand that you can add 4 plus 7 in your head and get 11. But if your teacher does require that, that's important to write it down. Right? But 4 plus 7 is 11, so you can just go straight from this to that equals x to the 11th power. Right? So again, multiplying with the same base. Right? Because remember, I have 4 x's multiplied here, I have 7 x's multiplied here. So altogether, I have 11 x's being multiplied together. Right, when you're multiplying here, don't multiply those exponents, add them up. Alright, so I get x to the 11th there. Alright, similar one for number 4, y to the 4th times y to the -7th power. Alright, so that's going to give me y to the power of 4 plus -7. So what is 4 plus -7? Well, that's -3. So I end up with y to the -3 power. Now, one of the things when you're simplifying exponential expressions, a couple of rules that we want to go to. We want to condense everything together so that there's only one of each variable. So in other words, if I have 2 x's in my original expression, I don't want to stop until I have just a single x. Right? I have 2 y's here. It's not simplified until I have just one single y. Right? So we want to combine all the variables or bases together that we can. The other thing about simplifying is we don't want to leave any negative exponents behind. Right? So if your answer has a negative exponent, in most cases you need to change that into a positive exponent. And the way we do that is similar to what we did up here in example number 2. Right, y to the -3rd power is the same as 1 over y to the +3rd power. Right, so if I have a negative exponent, I just take the reciprocal of it, and when I put that y to the 3rd power in the denominator, the exponent becomes positive. All right, so that's example number 4. Number 5, c to the 9th divided by c to the 5th. Right, so remember, when I'm multiplying with the same base, I add the exponents. When I'm dividing two things that have the same base, I subtract the exponents. Right? It's always the top one minus the bottom one. Right? And 9 minus 5 equals 4, so I end up with c to the 4th power. Right? Remember, the reason why that is I have 9 c's multiplied up top and 5 c's on the bottom. The 5 on the bottom are going to cancel out 5 of the ones up top, which is going to leave 4 behind. Right? That's why we subtract those. All right, so c to the 9th divided by c to the 5th equals c to the 4th. Number 6 here, b to the 4th power in parentheses raised to the 5th power. Right, so if you recall this law of exponents, when I have a power raised to a power, I need to multiply those together. All right, so b to the 4th power raised to the 5th power is b to the 4 times 5, or b to the 20th power. Right, so that's our rule with a power to a power. You just multiply the two exponents together, keep the base the same. And for all of these rules here, you keep the base the same. Right, number 7, I have 3x in parentheses raised to the third power. Right, so remember, if I have multiplication or division, like in example 8 here, if I have multiplication or division within the parentheses being raised to a power, I can distribute that exponent into the parentheses and raise each thing to, in this case, the third power. So that's 3 to the third power times x to the third power. And 3 to the third power is 27. All right, so 3 times 3 is 9. 9 times 3 again is 27. That's 3 to the third power. Right, so 3x in parentheses raised to the third power is 27x to the third power. Right, remember, the parentheses, the symbols that you see are important. Right, that third power outside of the parentheses here means that everything inside that parentheses is being raised to that third power. All right, so a common mistake I see on something like this is people say, oh, well, that's 3x to the third power. Right, because the x is to the third power. It's not just the x, it's everything inside the parentheses, so make sure you distribute that 3 to both the 3 and the x. Right, and same deal here on number 8 with the division, that x over 2 raised to the fifth power, well, you distribute that 5 to both of those things, so that's going to be x to the fifth power over 2 to the fifth power, and 2 to the fifth power is 32, so I get x to the fifth over 32. All right, and that is the value of x over 2 in parentheses raised to the fifth power. All right, so again, with multiplication and division raised to a power, you can distribute the exponent inside the parentheses. Remember, that's only for multiplication and division. If you have addition or subtraction inside the parentheses, you cannot just distribute the exponent. That's something we'll cover in another video as far as how to deal with that, but that's not one of the laws of exponents. All right, the laws of exponents as far as distributing only apply to multiplication and division. I've said it like 3 times in the past minute because it's a mistake people make all the time, so be careful for that. All right, I'm going to pause this recording here and erase these examples and put up some more examples that are a little bit more complicated, combining some of the rules together and having to use multiple of the laws of exponents in a single problem. All right, back here with a couple more examples. I only put 2 up here this time because these ones are going to be a little bit more complicated and take a little bit more time and a little bit more space to actually figure out. It's not like a one-step thing for these types of problems. All right, so example number 9 here, I have 2a to the third power b squared times 3ab to the fourth power, but that whole thing raised to the third power. All right, so if you recall the order of operations, the PEMDAS, right? Since this parentheses here is being raised to an exponent, I have to deal with that exponent before I can actually multiply this parentheses times that parentheses, right? Exponents comes before multiplication. So I need to basically take this third power out here and distribute that to all the stuff that's inside that second parentheses, right? And since all this stuff in here is multiplied, 3 times a times b to the fourth power, remember, if it's multiplication inside the parentheses, I'm allowed to distribute the exponent. All right, so this is going to equal, I'm still going to have 2a to the third b squared, and then I'm going to have 3 to the third power, a to the third power, b to the fourth to the third power. All right, so everything inside that second parentheses, I got raised to a third power because all that stuff was being raised to that third power outside the parentheses. All right, so that's going to give us, and it looks like I didn't even leave myself enough space for this problem. It's going to be 2a to the third power b squared. Notice I haven't touched that first parentheses yet. I need to kind of simplify that second parentheses before I can actually combine those together. Right, and then that's going to be multiplied by 3 to the third power, which is 27. All right, 3 times 3 times 3. A to the third power, and then b to the fourth to the third power is going to be b to the 12th power, right? Remember, when I have a power raised to a power, I multiply those two exponents. So I do 4 times 3 and get b to the 12th. All right? And notice, we're using multiple of the laws of exponents here. So for problems like this, it's really important that you understand the laws of exponents and that you know how to use them, and you use them at the appropriate times, right? Stuff in parentheses raised to a power, I got to take care of that first. I have a power to a power, let me simplify that. And now I'm just multiplying all the stuff in this parentheses times all the stuff in this parentheses. And since there's no addition or subtraction in either parentheses, basically I just put together the stuff that goes together. So I multiply the numbers. 2 times 27 is 54. Right? I multiply the a's. A to the third times a to the third. When I multiply two things with the same base, the law of exponents say I add those exponents. So a to the third times a to the third is a to the 6th power. Right? I add the 3 plus 3. And then I have b to the 2nd power times b to the 12th power. Once again, multiplying, so I add the exponents. 2 plus 12 is going to give me b to the 14th power. All right, so this original problem that I had up here, when I simplify it, it equals 54a to the 6th, b to the 14th. Right, and I know I'm done because I only have a single base of a, I only have a single base of b, and I don't have any negative exponents. There's nothing else I can do here to simplify this or combine anything together. I'm finished. All right, remember, different bases like the a to the 6th, b to the 14th, there's nothing that I can do to combine those two together because they're not the same base. Right, so that's when I'm done with this one here. All right, so that one took a little bit of work to figure out. Again, applying multiples of the laws of exponents to do it. For example, 10 here, I have x over y raised to the 3rd power times y squared x over z raised to the 4th power. All right, so here, kind of similar to what I had up here, I have the two parentheses. This time, though, each of those parentheses is being raised to a power, and also each of those parentheses involves a fraction, which means this one's going to be probably a little bit more complicated than that last one was. All right, so first thing I'm going to do is, just like the first thing I did up here when that parentheses was raised to a power, I'm going to distribute that exponent to all the stuff inside the parentheses. So for the first one, x over y in parentheses to the 3rd power, that's pretty simple. That's just going to become x to the 3rd power over y to the 3rd power. All right, just distribute that 3 to both of those things inside there, and that's what I get. All right, same idea for this next parentheses. Y squared to the 4th power. Well, when I have a power to a power, remember I multiply, so y squared raised to the 4th power, I multiply the 2 times 4 and I get y to the 8th power, and then I'm going to have an x to the 4th power, and then in my denominator I'm going to have a z to the 4th power. Right, remember, since I have everything inside these parentheses is either multiplication or division, and so when I combine them together, or when I distribute that exponent, everything just gets that exponent of 4. All right? And now I can actually multiply these fractions together. So x to the 3rd, and then I have an x to the 4th up in the other numerator. So when I combine those, since I'm multiplying an x to the 3rd times an x to the 4th, I add the exponents, I get x to the 7th power. I'm going to have a y to the 8th and in the numerator and a y to the 3rd in the denominator. So if I combine those two together, since one's on the top and one's on the bottom, I have to subtract the exponents. And 8 minus 3 is going to give me a y to the 5th power. And then I have a z to the 4th power in the denominator. And I don't have any other z's to combine that with, so that z to the 4th power just stays in the denominator. All right, that's all that happens with it. All right, so here I combine the x's, x to the 3rd, x to the 4th. They're both in the numerator, so I multiply them. I add the exponents, x to the 7th power. The y to the 8th over the y to the 3rd. One's on the top, one's on the bottom, so I subtract. I get y to the 5th. And then the z to the 4th all by itself there. All right, so those are a couple examples that get a little bit more complicated because we have to use many of the laws of exponents to do a single problem. I'm going to pause this one more time and put up probably one more example is all we'll have time for that might be even a little bit more complicated than these two. All right, last example that we'll do here, I think it's example 11. I actually forgot after I erased the last one what the last example that was up there was. I think this one's 11. Doesn't really matter. We have 6s t to the negative 4 over 2s to the negative 2 t squared. All right, so we need to simplify this. So first thing, I have numbers here, 6 over 2. Forget all those s's and t's. What's 6 over 2? That just equals 3. All right, so I'm going to have a 3 in my numerator. Right, and 3 goes to the numerator. If it was 2 over 6, if the 2 was up top and the 6 was on the bottom, I would have a 3 in the denominator because that's like 1/3. But 6 over 2 is the whole number 3, so that 3 goes up in the numerator. Right, and then the s's here, I have s to the 1st power minus negative 2. Right, since I have an s to the 1st over an s to the negative 2, I subtract the exponents 1 minus negative 2, and same thing for the t's. I have t to the negative 4 minus 2. Right, I always do the top exponent minus the bottom exponent. All right, and then what does that give me? Well, it gives me 3s, 1 minus negative 2, that's 1 plus 2, which is 3. And then t to the negative 4 minus 2 is going to be t to the negative 6 power. So that's going to be 3s to the 3rd power over t to the 6th power. All right, so I did those last couple steps pretty quick because we're running out of time here, but so since I have the fraction here, the same base, one over the other, I subtract the exponents. If it comes out to a positive exponent, I just leave it in the numerator. If it comes out to a negative exponent, I have to put that negative exponent in the denominator, and then it turns to a positive. So those are some examples.